Rajasthan is widely understood as an arid, monolithic desert, but plunging down into the southeastern corner of the state reveals dense, dry deciduous forests and deep rocky ravines. This is the Hadoti Plateau, an anomalous geographic footprint covering roughly 24,000 square kilometers across the districts of Kota, Bundi, Jalawar, and Baran. This map shows two distinct geological worlds. The ancient Aravalli Range collides abruptly with the massive Deccan Volcanic Plateau. Tracing the boundaries, the Aravalli boxes the region to the northwest, while the Malwa Plateau anchors the south. The structural fissure separating these domains is the Great Boundary Fault. Immense compressive tectonic pressures drove this reverse fault zone deep into the crust, fracturing the bedrock and creating precise channels that dictate where mineral deposits accumulate and how groundwater flows today. The modern ecology, the specific type of agriculture, and the urban layout of southeastern Rajasthan are direct, biological outcomes engineered by this deep earth collision. To understand the plateau's architecture, we begin with its structural basement. This foundation is the Vindhyan supergroup, a Proterozoic sedimentary basin comprised of massive, layered sandstones and weaker slates. Moving 66 million years backward to the Cretaceous-Paleogene boundary, the Indian tectonic plate drifted directly over the Reunion hotspot, an intense stationary mantle plume. The intense thermal pressure from this hotspot did not form a traditional conical volcano. Instead, it fractured the crust, triggering massive fissure eruptions. Deep, linear cracks expelled highly fluid, low-viscosity sheets of magma. This heavy magnesium and iron-rich basaltic lava flooded across the older Vindhyan sedimentary bedrock, burying it under immense thermal and physical stress. This map illustrates where these two rock types meet today. The orange section shows Deccan Trap basalt pressing against the yellow and brown Vindhyan supergroup bands. Evidence of this overlap is concentrated in specific zones, particularly the Uppermal Plateau, where basalt rests over ancient stone. Stacking dense volcanic basalts over porous ancient sandstones created a landscape of extreme chemical and physical tension, a foundation destined to weather into the dense clay-rich soils of the modern plateau. Exposed to surface water and atmospheric carbon dioxide over millions of years, that raw basaltic lava is highly chemically unstable. Water molecules and carbon dioxide aggressively interact with the iron and magnesium lattice in mafic basalt, breaking the rigid mineral lattice into distinct flat clay particles. The microscopic plates slide apart, transforming into dense smectite-rich clay that absorbs massive amounts of water between its layers. The macroscopic result of this continuous chemical weathering is Rager, the heavy black cotton soil that covers the Deccan Highlands today. Because it derives entirely from the volcanic basalt, Rager is exceptionally rich in iron, lime, calcium, and magnesium, while remaining notably deficient in nitrogen and phosphorus. The smectite clay also gives the soil a unique self-plowing property. It swells heavily when saturated, then shrinks and fractures into deep, jagged cracks during dry seasons, naturally churning the earth. This deep-time chemical weathering engineered an expansive, moisture-retentive battery across the plateau, strictly defining exactly what plant life could survive the semi-arid climate. This flowchart maps the plateau's two divergent physical realities. It splits geographically into the Deccan Highlands, defined by volcanic extrusions, flat-topped mesas, and heavy black soil, and the Vindhyan region, where exposed sedimentary rock forms massive concentric sandstone escarpments dominating the horizon. The primary hydrological engine exploiting this fractured, dual-natured topography is the Chambal River and its tributaries. Flowing from south to north, the river system leverages the existing tectonic weaknesses, aggressively carving its way straight through the massive bedrock fault lines. This relentless hydrological pressure hollows out the landscape, generating the extensive ravine systems and narrow, deep gorges that define the basin's edges. The Chambal River effectively acts as the region's circulatory system, binding the dense volcanic soils and the steep sedimentary rock together into a single cohesive watershed. Up on the rugged sandstone hills and plateau tops, the rocky terrain and extremely thin topsoil act as a strict biological filter for plant life. Only the highly resilient tree species of the dry deciduous biome, like doke and care, can dominate this rocky environment. Their primary survival mechanism is to deliberately shed all their leaves during the intense heat of the dry season, halting transpiration to conserve whatever moisture their deep roots can reach. This map of the region's protected areas highlights how this specific, harsh biome, marked here in yellow, seamlessly connects the Mukundra Hills Tiger Reserve to the Ranthambore system, providing the exact cover and breeding grounds required for large apex predators. Without the ancient tectonic fracturing that pushed these rocky uplands toward the surface, the existence of the Mukundra Hills Tiger Reserve and its leopard and tiger populations would be geographically impossible. Down in the plains, the deep, moisture-trapping regger soil creates an entirely different reality, operating as an agricultural powerhouse. Despite this semi-arid climate, the clay's ability to hold water allows for the mass cultivation of highly water-intensive cash crops like cotton and soybean. This agricultural density, paired with intense stone mining operations, has driven rapid urbanization and heavy industrial expansion, particularly around centers like Kota. The critical failure point in this expansion is municipal and industrial wastewater outstripping the city's treatment capacity, resulting in direct discharge into the Chambal River. This concentrated runoff actively alters the river's precise water chemistry, placing direct pressure on the survival of the endangered aquatic species, like the gharial and the gangetic dolphin, that rely entirely on the deep gorge systems. The Hodoti Plateau is a locked, inseparable system. The ancient tectonic fractures, the volatile soil chemistry, the river hydrology, and the modern industrial economy are bound together by geography. A failure in the modern management of the river threatens to collapse a balance that took millions of years to assemble.